Welcome back again, class. Today we're going to be moving into 10-4. But before we begin these notes, we are going to do some more final review. So, quadratic formula. This was a huge topic for us. So let's recall first, what actually is that quadratic formula? Well, we're talking about negative b plus or minus square root of b squared minus 4ac all over 2a. So let's start plugging this in, recalling that 3 is going to be our a, the 13 is our b, the negative 10 is our c. So negative b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. So recall that we begin just by plugging everything in where it belongs. Now, after that, remember the thing that I simplify first is this beast under the square root. So 13 squared minus 4 times a times c. When you calculate that out, you actually get the square root of 49. Now, hopefully after all the stuff we've been doing, you recognize that 49 is a very special number. Hopefully you recognize that 49, when you square root it, you actually just get 7. So, when we take the positive, we get negative 13 plus 6, or plus 7, which is going to be a negative 6. Wrote it again. I apologize. That gives us a negative 6 divided by 6 is a negative 1. Then when we subtract it, negative 13 minus 7 is a negative 20 divided by 6. Well, negative 20 divided by 6, that is going to give us negative 3.3 repeating. All right, now looking at just going back a little bit to last chapter, factor and cancel. So simplifying these rational expressions. Recall, I can pull a 3 out of both of those terms, and I can pull a 2 out of both of those terms. When I do that, once I factor, I can cancel what is the same top and bottom, and I'm going to get 3 halves. So that's from our final review. Now, I also want to take a second to review some of the concepts we did back in 10.3 because those are still going to remain important moving forward. So when we're adding and subtracting, we're looking for like radicals. So here we have 4 square roots of 3 plus 1 square roots of 3. So those two things are like radicals because they have the same radical piece. 4 plus 1 just gives us 5 of the square roots of 3. And then we're done. All right, now the next one is still subtraction. However, what I want you to realize is look at that square root of 24. All right, so that square root of 24 actually breaks up into 4 and 6. So it becomes 2 square roots of 6. So once we exchange that out, our problem is actually 3 square roots of 6 minus 2 square roots of 6. Okay, once we reduce that second radical. Well, now we have the same thing in our radical. So we can actually subtract those. 3 minus 2 just gives us 1. So we'll just have 1 square root of 6. Or if you prefer, you can just say that is the square root of 6 as our answer. And then finally, our multiplying problems, okay? I have a single thing outside of a parenthesis trying to multiply it. So I'm going to multiply it in. I'm going to distribute it. Square root of 7 times square root of 3. Well, both are inside the square root, so they combine to be the square root of 21. Square root of 7 times negative 2. Well, the negative 2 is outside the square root, and then the 7 has to stay inside. So, just quick review of what we did last time. So, let's dive into our new stuff. We're going to be talking about solving radical equations now. So now we're not going to be just simplifying and reducing anymore. They're actually going to be in the form of an equation, and we are going to have to solve it. Now, you can see on the side, I have step-by-step instructions of what you're going to have to be able to do in order to solve these. The first thing, isolate the square root. Now, what do I mean by isolate the square root? Well, I mean get it by itself. All right? So you see the square root here. Well, to get it by itself, right now it has that plus 11. So what do I do to get it by itself? I'm going to have to subtract off that 11 from both sides. So that's going to give me the square root of x. That cancels. It's going to give me the square root of x equaling 10. So my first step is done. I've isolated my square root term. Next thing, it says to square both sides. All right, so squaring both sides, well, squaring and square roots, you already know, undo each other. So what that means is on this side, I just have my x, okay? And 10 squared is 100. And look at that. I've already got my answer. So these really aren't that bad as long as you follow these simple instructions. So let's try stepping through the process again. So the first thing I want to do is I want to isolate my square root term. I want to get that square root of x by itself. Well, to do that, I'm going to have to add this 5 over. So now I have the square root of x. Negative 2 plus 5 gives me a 3. All right, so now that I have the square root by itself, now I'm going to square both sides. Again, that undoes the square root over here. And 3 squared is 9. Now, once again, I already have my answer. X equals 9. And if we wanted to check that out, make sure that that actually is a true solution. Look at what we can do. So we plug x, or we plug 9 in for x. So we get square root of 9 minus 5. Well, that's just 3 minus 5, which does, in fact, equal negative 2. So you can always go back. You can always plug in that answer to see, does it actually work in the original problem? All right? So those are the basics. Well, what about when the root is on both sides? All right, well, when the root is on both sides, we a little bit mixed up the order. We're going to start by squaring both sides in this case. Okay, because we want to get rid of those square roots. So if it's already on both sides of the equation, just square both sides. When you square a square root, you just get back whatever was inside. So both of the square roots just actually disappear. Now we have this. So now we actually just have to solve a linear equation. So I want to get my variable to one side. So I'm going to subtract m off of both sides. So I have 2m over here minus 6 equals 23. Well, I need to get my number on the other side, so I'm going to add 6 to both sides. So I get 2m equals 29. And now I'm going to divide by 2. So m equals 29 halves, or if you calculate that as a decimal, that is 14.5. All right, let's try another example of this to see how it's going. So again, I have a square root on both sides of my equation. So I'm going to right away square both sides. So that gets rid of the square roots that I had on both sides. And now I'm ready to start solving. I need to get my variable to one side of the equation because I have something linear here. So I'm going to subtract 5x from both sides. So 2x minus 4 equals 10. I'm going to add 4 to both sides. So 2x equals 14. When I divide both sides of my equation by 2, that's going to give me an x equals 7. And that's going to represent the end of my problem. All right, now this last one is a little bit different. Notice we have that 2 sitting there. So when we square both sides, I want you to realize we're also squaring that 2. So we have to be careful. So over here we're getting r plus 5. Squaring undoes the square root. But here we actually get a 4 with the r minus 1. The square root still cancels, but the 2 actually gets squared. All right, and now that we have that, now we're going to distribute that out. So we have r plus 5 equals 4r minus 4. And now we start maneuvering things around just like we were doing before. I want my variable on one side, so I'm going to subtract r off. So I get 3r minus 4. I'm going to add 4 to both sides. So 9 equals 3r. Divide both sides by 3. So I get the r equals 3. All right. So once again, I want to thank you for joining me for this. So please make sure you have everything written down from this video, and then tomorrow we will continue our practice work.